In this video, we are going to discuss about signature recognition. When we come across the term signature recognition, we typically have two tasks in mind. One is to find out the user or the owner to whom the signature belongs to, and the next task is to finding out whether the signature is forged or not. So for this, we can build a deep learning model which does entirely all the job, but instead we want to implement all our traditional methodologies of finding a forgery image by using Python in Jupyter notebooks with the help of some libraries. So the first step what we do is build a model which recognizes the user who the signature belongs to, and then we will be implementing all the traditional methodologies what we follow in evaluating a forgery signature by using our metrics. So the criteria which we look for while we are finding a forgery image is, the first one is initial impression, that at the first step we find out how far the new image, new signature differs from the genuine image, and then we find out the length of signatures, and then we find out the small breaks in between the letters or the blocks in the signature, and we find out the unusual ink bolts, and we find out whether there are shaky lines in between the signature, and we find out whether there are signs of retouching, that is whether there is a signs of lifting the pen and keeping again, those kind of signs, and then we find out proportions of the letter sizes, and then we will look for other differences that are not in common with the genuine signature. So what we will do is we implement these different criteria by using our Jupyter notebook. So what we will do is we import some libraries of Keras, TensorFlow, SQLite 3 for storing the images in a database, and skimage and Scipher. What we will do is we will extract that signature in the form of a image file as a PNG or JPG file, and then we will evaluate our metrics. At the very best step, we make a deep CNN model which recognizes the user who the signature belongs to, and this model also gives us the probability of how much the new image belongs to that user. So then we will find out, we will take a genuine image for that user, and then we will compare this new image with that genuine image, and we will find out the metrics. For that, very best metric is structural similarity index. It just compares all the different objects in the images and gives us a score. So next metric, though the root mean square distance metric is not appropriate in this context of comparing two different images, but we still have to get those distance metric. And then we find out the number of objects in an image. That is, for each different threshold intensity, we calculate this number of objects, and then we make a distribution of that, and then we compare the distributions by using z-test and the t-test. And the next metric is we compare all the threshold intensities. So we have some functions which gives a threshold value of the intensities when compared to all different range of intensities in our image. So by using O2 or isodata, mean, minimum, triangle, light, and different functions, we find out different thresholds, and then we compare those thresholds values of the new image. And we compare all the objects. The way or the traditional way of comparing the letter proportions is implemented in this method. We extract all the different objects, and then we compare each different object. And then in this method we compare the intensities. We make a histogram of all the frequency of intensities, and then we compare those intensity distributions. And then we find out a cumulative distribution of those intensity values, all the intensity values, and then we use the z-test and the t-test to evaluate those distributions. In metric 8, we center the image. We find out the center of mass of our genuine image, and then we make new image to have the same point of the center of mass, and then we compare those images. And at metric 9, we apply many filters, especially the sawbill filter, which we implement, typically captures all the differences in the edges or the lines, whether it comes to shaky lines or it comes to difference in some edges, with the very minute level of fractions also are captured by the sawbill filter. And then we use other filters as well, like Gaussian filter, percentile, minimum, maximum, uniform filters, to find out all the different variations or the differences in a signature. And then we find out a final score which will be helpful in finding out whether the signature is forged or not. So in my data set, I have 44 different users, and I have collected one genuine image and one forgery image for all these different users, and then I compare them with the genuine ones, and I have evaluated the results. We can say when a genuine image is compared with a genuine image, our model is accurate to about 90% that it is genuine image, and forgery image are also accurate in finding out whether the forgery image is indeed a forgery or not. So as there are different resolutions, different sizes, and different data types in these different images, there is a need of many data processing functions which I have implemented. And at the last, I have made some useful visualizations for comparing of how our metric perform. Like here, I compared a genuine image with a forgery image. The genuine image is to my left and the forgery image is to my right, and then I have plotted the distribution of number of objects at each different intensity level, making as a threshold, and then evaluated the distribution. Then I have made a plot of frequency of intensities, all the image, all the intensities in the image, and then plotted threshold intensity and then I plotted all different results for the genuine and the forgery image, and we can compare how these differ in both. And then I made a relay which extracts the signature from its background, and then I plotted all the different objects that our model has extracted in the images. And then at the last I have even plotted our images along with their center of masses. So thank you.